Hello everyone. Welcome to the course of Digital Logic Design. In today's class, we are going to learn a topic called block parity. So, what is this block parity initially? In yesterday's class, we have already seen what is a parity and how it is differentiated, what is an even parity and odd parity, right? Now, we are hearing a new term called block parity. So, in block, the collection of bits can be regarded as a block of data. Block of data. So that means it will be having rows and columns. Okay. So the parity bits can be assigned to both rows and columns. Rows and columns. So let us consider a block of bits. Okay. So let us consider the block of bits where let me draw the block. So the block is 0, 1, 1, 1. 0, 1, 0, 1. 1, 1, 0, 1. 1, 1, 1, 1. Let us say these are the block. These are the block of bits we have. Okay. Now let's consider the type of parity. So let us assume this particular block of bits should be odd block parity. Okay. So for each and every row and column, we need to check the parities now. So let us say this is row and column. Okay. So row parities. So we need to see, as we are considering it as odd block parity, we need to see that number of one should be odd. Okay. Now let's check the row. So the number of ones is already 1. So the parity bit should be 0 in order to keep the data as odd parity only. Okay. So if you see in the second blocks, 0, 1, 0, 1 is the even parity. So we need to add 1 in order to make it odd. Okay. So 1101, it is already in odd parity. So what we can do? We can put 0. Okay. And all 4 ones is the even parity. In order to make it odd, we need to place 1. Okay. Now let's see the common parities. Column. Okay. So 2 ones are the even parity. In order to make it odd, I need to add 1. 4 ones are even parity. In order to make it odd, I need to add 1. 2 ones are even parity. In order to make it odd, I need to add 1. 4 ones are again even parity. I need to add 1. Okay. Now, if you see this particular block over here, so this is the corner bit. So if you see in this particular column manner, 4 ones are there. In order to make it odd block parity, I need to add 1 over here. And if you see this row particular, the row number of ones are 2. To make it odd again, I need to add 1 bit. So 1 bit will be common for the last bits of the row and column. This is for the odd block parity. Okay. Now let's see an even block parity. Even block parity. Even block parity. Okay. So let us draw a block. Okay. So the first block will be 0, 1, 1, 1. Okay. Second will be 0, 1, 0, 1. Third will be 1, 1, 0, 1. Fourth is 1, 1, 1, 1. Okay, so these are the block of bits considering for the even block parity. Even block parity. So now to make it even block parity, so this is row and this is column. Okay, for an even parity. Okay, so for an even parity, number of ones should be 1. So here, if you see here, there are only 3 ones. So add 1 to make it even parity. Here, if you see, it is already 2 ones are there, which is even. So add 0. So 3 ones are there, add 1 to make it even. 4 ones are there, add 0. Okay. Now, this one also. 2 ones are there, add 0. 4 ones are there, add 0. 2 ones are there, add 0. Again, 4 ones are there, add 0. Okay. So if you consider the row and column, the corner bit will be our data bit. So if you see here for an even parity, it is 1, 1. Okay. In the row, that means already this particular area will become 0. Why? Because we already have an even parity.